Welcome, everybody, to our AI Jam series. This is AI inferencing at the edge, use cases from Earth to space. It's February 12th, 2025. We're lucky to have our two guests today, Michael and Mark, who've been helping customers build AI solutions at the edge and equip them with advanced use cases in our federal and public sectors for many years. Michael Green is a senior enterprise solution architect at Hewlett Packard Enterprise. Before starting his now 6-year tenure at HPE, serving our federal sector customers, Michael served in the U.S. Air Force as a cyber systems operator. Dr. Mark Fernandez is currently the principal investigator for the Spaceborne Computer 2 project and the chief scientist for space technologies and solutions at HPE. Dr. Fernandez remains a payload developer for software for SBC2 and leads the software development team, which continues the advanced development of the quote, hardening with software architecture. Mark earned his PhD in scientific computing and his master's in computer science from the University of Southern Mississippi. Welcome to you both. Michael, we will start it off with you to tell us a little bit more about yourself and your role and what makes you excited to start each day.
Okay, thanks for that. Excuse me. Thanks for that intro, Audrey. Thanks for the opportunity. So, like Audrey said, my name is Michael Green. I'm an enterprise architect here at Hewlett Packard Enterprise. Been with the company just over 6 years, and then prior to this, I was in the Air Force for 20 years. So, various assignments all over the world, various jobs that I was able to take part in all over the world. And what gets me up in the morning and what really drives me is serving my customers. And what I mean by that is I work in the federal space. So I go out every day and I see customers that I used to work with, work for, or work for me, right? So when I talk to customers about how HPE can help them with our various solutions, it comes from a deep understanding of their mission, um, their pain points. And I used to be the guy on the other side of the desk that was going in and having OEMs come and talk to me. So having that experience helps me with presenting a solution to help the customer get after a problem.
And how about the word balance that you put as one of your descriptors?
Yeah,
I mean,
so in my descriptor, I said passion, obsession, and balance. And basically, anybody that knows Mike Green knows that when it comes to technology, I am very, very passionate to the point of being obsessive. I get up and I think to myself, hey, what can I learn today? What solution is going to help my customers? And with that obsession, that passion and that obsession is finding a balance between both of those, right? Because I sometimes, when I was in the Air Force, I get a solution and I'm just hours on end trying to figure it out, right? So finding that work-life balance, and that's where my descriptor comes from.
yeah, it's pretty easy to get lost in the flow of technology. Look up, and hours go by, and you're reading away, right?
Absolutely.
And Mark, how about yourself? Tell us a little bit more about your role and what makes you excited to start each new day.
Sure, glad to be here. Thanks for having me. Thanks for the introduction. I appreciate all those here in the audience. Good to be here with you, Michael. So yeah, I'm pretty much dedicated to what I call partner success. So every morning we get up and we fire up our laptops and we log in. I get to log into a computer on the International Space Station and get to be dedicated to showing how valuable it is to explore that balance between cloud computing and edge computing and working together. So I'm pretty technical. We always like to talk about with a technical solution, you can get things that are faster, better, or cheaper. I really focus on faster. We're out there at the edge of the edge, and that's where the data is. I can compute faster than you can download. So rather than getting your data down to the data center so you can do what you normally do, I like to show them how we can have a technical solution that's very efficient, that gets you your results from months to minutes or from days to hours. And so I'm really focused on that and focused on the efficiency, taking all of the suite of technical solutions that we have that Michael and I are going to explain later today and improving your performance, giving you better results. So I'm looking forward to today. Thank you for having me.
Mhm. Yeah, happy to have you both. And Mark, I think one thing I that came to mind when we first met was, how did you become interested in space?
Oh gosh, that's
Maybe that's a
so
long that demands a longer time period.
I actually have a rejection letter from NASA where I applied to be an astronaut. Back in the day, you had to have 20/20 vision, and of course, I didn't have it. So I was actually very prized to have that. So I've always been fascinated with the latest technology. And of course, space is the latest technology. And to be able to mix my passion of computer science and scientific computing with helping out other partners in their success in space is just, I've got the best job in the company.
Mhm. I love that. Thank you for sharing. So let's just jump right into our topic for today. So we're talking about inferencing at the edge. And so we're going to just level set on some terminology that we use to say, okay, well, what is inferencing and what does that mean in the realm of AI, and how is that different than training? So um, when we talk about inferencing is the moment where we're producing a result or we're generating some kind of response based on new data that we have from learned parameters. So you can think of it as you've already studied for the test, and now you go in and get asked a new question and you need to respond to the answer. You can insert any kind of analogy you want on that. Sports, right? You've done all your athletic training, you've run all your plays, you know how to play the game, and now you go in and you play a new team, and you need to think on your feet. So that's what we mean by inferencing. There's some different data management strategies, and Michael and Mark we'll talk all to these different data strategies, particularly for space. It's more complicated in that type of environment. Where is data stored? How do we access it? Are we moving it or not moving it? Some other things that are interesting for inferencing is a need for speed. So unlike training where you say, okay, we'll take a long amount of time, right, to train large models. It could, be days, weeks. On this, for inferencing, we want something immediately, right? We might wait a minute, but maybe we want it in seconds. Maybe we want it within an hour. The other thing that comes up is this connectivity and power constraints, and I think we'll talk a lot to this today. Inferencing typically happens closer to uh, where somebody is at. So this is particularly when we're talking about that at the edge, and so you might be in environments that don't have full, data center power capabilities, or if even network connectivities. And the models, in this case, for inferencing, they're on location. So we need to, store that model where we're inferring it. And unlike training where it's at maybe another location and we can just call to it. Am I missing anything, Michael, Mark, on what else does inferencing entail, some qualities of inferencing?
It usually takes a large amount of data and quite a little bit of time. And now the world is focused on how much electricity that's going to take. So to get the training done, the whole goal is to get you down to a very small, efficient inference engine that will run on your cell phone or your edge device, etc.
Yeah,
Yeah,
it's
great
a good
point too.
point. Oh, go ahead, Michael.
No, I was going to say great point, Mark. And when we talk about edge solutions, that's one of the key things that I talk to customers about, right? So when we want to do more processing at the proverbial edge, we have to take into those power considerations, right? So typical hardware, when you're doing basic compute, that's a certain, degree of power that's associated with that. But if you're talking about doing actual, training and inference at the edge, that's additional power we have to account for. So that's some new conversations that I'm having with customers to make sure that they're taking that into consideration on their AI journey.
Mhm.
Yeah, I think there's some power metrics out there that talk about GPT-3 using 1,287 megawatts per
Mhm.
hour for training. And so we're just huge
Mhm.
amounts of power versus when you're doing inferencing, you could be on a small scale. I read 2 watts as the smallest and maybe up to 75 or more, depending on the
Mhm.
setup for inference. So a difference, but still significant and could add up. And then, so with the edge location as well. So when we say edge, we mean something that's just, it's not in a data center. So it's not a centralized center of computing capacities, connectivity, and power. And there could be multiple as well. So we think of edge also as like near and far, and there is different maybe perimeters of locations. And we'll put up a poll here that in a second that talks about what edge locations you all are looking at right now in trying to manage, again, different data management strategies. And again, getting the edge is closer to the people, it's closer to the operations, if it's say like manufacturing sites, things like that, as opposed to remote sites for data centers. And then there's typically some kind of resiliency element that's needed for both physical and for software. So can things operate in an offline manner? Can they withstand shock or heat or any other kind of element? So I think we've got a poll up. Did I miss anything, Michael, Mark, on what else is edge like?
No, I think you did a great job there, and also too, to my fellow presenter there, Mark. I think between our talk tracks that we're going to present today, I think we definitely encompass what the edge is. For me, edge outside of the data center, and then for Mark, edge, off planet. So I think it's a great combination there, and also too, Mark, to Mark's earlier point talking about cloud computing, doing that, in space. I think maybe about 15 years ago when companies were talking about cloud, right? You were trying to figure out where's the cloud, what is the cloud, right? I think Mark, you've taken that to a whole nother level when you talk about cloud computing.
Yep. Okay, so we have a poll up there. We have what computing edge locations are you focused on today? So it could be multiple, but we think of some as stationary sites. So these can be retail locations, hospitals, any other large facility. Inside of that, there could be equipment that you're managing, mobile sites, small stations. So these can be, again, like another edge site is a larger building, but inside of that, you could also have, say, operating room or kiosks that have some kind of vision capabilities or IoT going on. So curious what kind of edge people are experiencing. The next question is, where do you need inferencing to take place? Is it both the edge or at the data center level? And then this one's a little bit of a brain teaser question. Sorry for, for all our audience out there, but if you can get this right, I think you don't need another cup of coffee for the day. So put your hand down if considering or adopting AI use cases is not part of your 2025 goals. So let's see what our results are. Okay. Great. So it looks like most people out there are dealing with some kind of stationary sites and that they might have multiple of. across different locations. And the biggest is all of the above. So I think this really validates our point around the edge can mean a lot of different things, and it has a lot of different types of requirements that go with it. And then where do you need inferencing to take place? This is really interesting. I think, yeah, the comment of both. So yeah, inferencing can take place at site at the edge, but it can also take place within a data center, depending on the applications and the use cases. Okay, and we got a little bit of a brain teaser on the bottom. So most people, half the audience, did say that AI is part of the 2025 goals. 15% put their hand down and said no, and another 37% said I don't know. So the I don't know is interesting because it means that maybe this is coming up, but people haven't identified maybe necessarily the use cases or haven't been asked to deliver on something yet, but maybe it's coming. Okay, so we're gonna dive right in to some of your public sector use cases, Michael.
Hey, thank you. So, as I said before, like I said, I work in the federal team public sector, right? And the reason I picked these specific use cases because these are near and dear to me for the various jobs that I did while I was in the Air Force, right? And I saw the proliferation of numerous amounts of raw data. And by raw data, I mean for various organizations that I work for, we would just get inundated with numerous publications for how to do a certain task, right? So we had tactics, techniques, and procedures, TTPs, for how to do a specific task, and it outlined exactly how you did said task, right? So because there were so many tasks, um, if you had to go back and reference a previous task that you did, it would say, hey, let's go look here, let's control F, try to find what I'm looking for. And the two, use cases that I'm talking about are specific to those particular areas. So for the example on the left, for RAG, retrieval augmented generation, this particular use case takes a amount of data and then run some AI tools against it to give you a result. So essentially what it does is allow you to have I hate to use a nomenclature, but a chat GPT type interface to talk to your data. And what I mean by that is I'm going to make the assumption that everyone is familiar with chat GPT, right? So you go to a web interface, you ask, chat GPT, a specific questions, and then it's going to generate a response for you. So we've basically taken that and said, hey, let me give you a subset of data, run some large language models against that, and then give me a result. And what I mean by that is if I have a document, I'll use a document, for example. If I have a document, that document says, hey, Mike, this is the exact way you need to do these procedures to run this operation, right? It's right there in black and white for how I need to do that process, right? So instead of me control F to find that, I insert this document into a RAG database, well, specifically a vector database, and that database indexes that file, and then when I want to ask that document specific question, I do that. So I go into a web interface, just like ChatGPT, and I'll say, hey, document, how do I do X? And it'll say, hey, I can change the prompt, to make it user specific, but here's how you do that. And I've done that too also with quick specs. So like I say, I'm a technical guy. Quick specs are my best friend, right? So for instance, for a DL380A, how many GPUs can I use in that with that server? So I would add that quick specs into that add that quick specs into that RAG database and ask the database, ask the instance about that server. So for DL388, how many GPUs are supported? And it would spit back the output, say, hey, Mike, there are eight, single wide, 8 single wide or double wide GPUs that are available to me. It can also tell me what specific GPUs are available to me. So I'm having a conversation with a document versus the traditional way of control F, find, and like I said, with the sheer amount of data that I would have to go through, it just really makes it really quick. And I'll give you one other example of RAG, and then I'll move over to the computer vision. One of the jobs I had in the Air Force, really fun job I had in the Air Force, was going out and hunting adversaries, right? And it's very prescriptive on how I do that, right? And there you get into some legal issues when you don't do things a certain way. So if I had the ability to say, hey, I'm going to location X, what things do I need to consider? And basically having a conversation with a document like I would if I was having a conversation with Mark or Audrey, right? So um, the speed to access really, pays dividends when you're trying to hunt adversaries. And I'll leave it at that. For the other use case, computer vision, we partner with an ISV. In particular, this one is Vadio, and we run a software called IronM, right? So I've deployed to numerous sandboxes, all over the world. And one of the key things that we run into is control point entry, right? So making sure that when people come up to a base, that we can identify said person to make sure they're not an adversary or they're not trying to do something nefarious, to the gate guards, right? So we can have a camera, as you see here on the right. Excuse me, on the right, we can have a camera pointing in a certain direction, and anybody that enters that area, we can identify that person by facial recognition. We can also use object detection, right? So for that camera, we can identify, a gun, we can identify, a backpack, and it takes the pressure off of that gate guard for them to focus on what's directly in front of them, and we can have that camera, kind of, miles out in certain instances, and it's really about protecting, all the members that are in that deployed area, and then also too, just for a simple, monitoring a single point of entry, right? So if you have a single point of entry, you have 15 people go in and then only 13 people go out, this particular software will give you the delta. So, those two additional folks that didn't make it out, hey, let's send a team out there and identify where those people are.
I really like the RAG use cases, Michael, that you've talked about, because so much of it too is around, we always talked about in software development, eliminating clicks, right? Okay,
Yes.
if we can help people do something in fewer clicks, then that was more efficient and it saved people time and it improved the user experience. And what you talked about in the terms of how do I find the information that I need faster is like eliminating clicks, because before, instead of even just to go look up your quick specs, right? Like some kind of manual that has information you need. Well, you need to go find the manual. And then you need to maybe go look up multiple, right? Because, oh, okay, it wasn't in that one, it was in another one. So
Right.
if you have a system that had already collected the relevant information that you would want to reference, then it's, I guess, not a click anymore. It's just a type.
And one key thing I want to focus on to with the RAG implementation is this data is local to you. You're running this application on-prem, where the data is, right? So I mentioned Chat GPT. Obviously, we know the company policy about putting proprietary data into Chat GPT. This is a system that's running completely offline, on-prem, and for specifically for my DoD customers, they don't have to worry about their data getting leaking out to the public internet, right? So we take this product, um, bring it on-prem, make various tweaks to it, to the customer's use case, and then that model lives with that customer, right? So they can ingest data, depending on what authority they have. They can even ingest classified data because that data never leaves the customer's location. And I think that's one of the key things. And I don't want to speak for Mark, but I'm sure there's very specific things that you do for space operations that you don't necessarily want on the public internet, right? So take the subset of that. It's on location. You run it. You ask it questions, and that data never leaves your premises.
Yeah, we'll get into a bit more details, but secure and trusted is always one of my little bullets when we're talking about inferencing at the edge, because the data was generated at the edge. The inference engine works at the edge and nothing leaves it, so you're kind of localized and secure. I want to bring up a couple of points, Michael, that you've brought up that are excellent. You're looking not only at PDF documents, but you're looking at computer vision. And to many, those may seem to be very, very different things, but under the umbrella of inference engines and artificial intelligence, they both fit and they're very efficient at the edge. So although they're very different, they are very important at the edge, and I use them both on the International Space Station. We'll cover that in a little bit. Just as you're using them at your entry point and you're using them with your documents, we'll use them with documents in space and we'll talk about EVA gloves. So this technology is pervasive, and we've got to get that concept out there that artificial intelligence covers both of those as well as a few other things. So good points.
Thank you.
And if there's any questions in the audience, there's a Q&A box that you can use to put in questions as well. So go ahead and use that and we'll answer them for you. And then Michael, I know we want to talk a little bit about, so what makes this run, and what are some of the cool things that HP does for these types of environments?
Absolutely. So I don't know if you were aware, but there's a company called HPE that makes really great hardware, really great hardware, right? And what you're looking at here is our Edgeline platform. So like I said, again, I work in the federal space, and for the edge, in my use case, it's anything that exists outside of that data center, and that edge could be, another installation. That edge could be, couple of meters back on the battlefield, right? And anything far in between one of those. And what I'm displaying here is our Edgeline platform, right? So just giving you different options here. So starting at the bottom left, the EL8000 came into market, I want to say in mid 2019. 2019, we started publicizing it, designed for telco, but adopted to DoD for my specific use case, right? So up to 4 blades of compute. You can see the stats there, 40 cores per blade, 30 terabytes of storage, terabyte and a half of RAM, a lot of dense compute and store in a really small footprint, right? So in the top right, this is what it looks like outside of that rugged case that you see there, but really small form factor, right? So you're talking about all that dense compute in something that can fit in the overhead bin of an aircraft, right? So I got the honor and privilege to go out with an Army unit in a live fire exercise in 2021, I believe, out in Guam. So this customer, this Army customer, flew from flew from Hawaii to Guam. I met them in Guam from Texas, and they flew from Hawaii to Guam with an EL8000 in a commercial travel case. And within, I would say, maybe 2 hours of us arriving on station, we were servicing their enterprise services off of an EL8000. So if you talk about traditional pizza box servers, you're not doing that, right? Nobody else has this capability. And also, too, when you're, talking about AI and inferencing, we can put GPUs inside of this server. So in one of those blades, we can go up to an H100 GPU inside of that kit, right? So in the bottom right, you'll see our EL8000 prototype, which is our single node. So we have an EL8000T, which is a 2U chassis with 2 blades side by side. One of our customers said, "Hey, HPE, you do great things for us." They're really happy with the EL8000 platform, but they want to get smaller and lighter. And we worked with them to cut that chassis in half. So what you see right there is the single node chassis, which is 1 blade of compute. But even in that 1 blade of compute, we can go up to an H100. This is game changing, right? So I'm in Colorado Springs now for an event. I actually flew from Texas with that in the overhead bin of an aircraft. So a lot of dense compute that we're able to take out, to the proverbial edge.
And Michael, what's
Michael,
swap C? Can you the swap seat.
Yes.
Sorry.
Yeah, and I think Mark will talk about this too.
Yeah.
Like when you're talking about, specifically for DoD, and like I said, in other areas too, right? But DoD is my bread and butter. Swap, size, weight, power, is one of the critical pieces, right? Because if you have all this compute, you still have to have the power. So when you're out at the edge, not all power is created equal. And what I mean by that is you'll have situations where you don't have clean power that's conditioned before it hits the hardware. The size plays a real consideration when deploying a solution, and also too the weight, right? So I talked about the weight of that system, talking about aircraft carry, or if you were to do traditional piece of box servers, the logistics that's required to take that solution from site A to site B, for something that's as small as the EL8000, we're able to take dense compute anywhere around the world, essentially in a backpack. Right? So it opens up opportunities that customers may not have had before in the past. And one of the key things I talk to my customers about, and what's a bit of a challenge sometimes, is because of what the systems that they were used to using, which were huge, sometimes pallets of equipment that were good for what they were designed for, right? There's been a paradigm shift. So the things that you were used to running in a data center, you can take those workloads and push those closer and closer out to the edge, right? And when it comes to specifically, cyber operations, you want to get as close to the data as you can to make real-time decisions. Because, like I said, the key thing that's going to be your adversary, besides your actual adversary, is time to put a solution on target.
So last summer at HPE Discover, our CEO announced that we are planning to go to the moon. And this is the platform that we are targeting to take to the moon with us because of those reasons you mentioned, Michael: size, weight, power, and capability. First, let me talk about the capability. I'm the software guy. So you see there's 4 servers. Well, I need one, and then I've got 3 cold spares. That makes me feel warm inside that I can continue to address the needs of my customers. And second point I want to make, our CEO also announced that we had the world's largest direct liquid cooled system. Well, when we get to the moon, we're not going to have any air or water. So we're going to be adding direct liquid cooling to the world's smallest data center and take that to the moon with us too. So
Really cool. It's very impressive. And I think, Michael, we also had one more visual just to show some of the progression. So we have the Edgeline 8000 in the middle here, but then we can go very small and we can go larger, and then as Mark was just saying, we can get into liquid cooled or direct liquid cooled, and then even supercomputers, right? So the whole progression.
Absolutely. And I said, and what you're displaying now is, like I said, the different various platforms that we can run, our AI on edge solutions, right? So not necessarily the Cray XD 670. That's going to be more, data center based. But just look at the various options that we have. And when you look across other OEMs, there's nobody in the market that can do what we're doing with the platforms that we have. So when I talk to a customer about, introduction into AI, and I talk about RAG, I talk about, computer vision, right? Some of them are a bit apprehensive because they think, this is going to take some huge amount of hardware to generate some results, right? And when I tell the customer, hey, these are the different options that you have. So if you have, a small, instantiation that we can set up, we can start that AI journey together in a very small footprint, let you kick the tires a little bit, get comfortable with the technology. And then as that, the more comfort, excuse me, the more comfortable you feel with that, we can expand on that, right? So, and one thing I'll foot stomp, and again, I may be a little biased, right? So starting at the top, right, with that DL 145, ILO, DL 388, ILO, EL 8000, ILO, it's a platform that you're comfortable with. So once you learn that ILO interface, you learn that server management across that platform, there's no difference, right? Slight difference in the hardware, but the management would be the same, right? So one thing that when I was in the Air Force that OEMs would come and talk to us about technology is one thing they never really, I think they never really took into consideration is the training effort, right? So when I had to go out and train airmen to do a specific task, there was a very structured way I had to do that. And anytime anything new was injected there, we have to go back through and redo that training, right? So I say that to say when you learn the management interface for an HPE server, that's going to carry on to that next platform, right? So there are going to definitely be some updates, but the core functionality is going to be the same across the platform, and that lessens the time, for training when we do, tech refreshes.
Yeah, and I know this got a little cut off on the slides. I think maybe lost in translation from desktop version, but that top one for the DL145, I think I heard an interesting use case where so those are L4s and they're single slot L4s, and you can put up to 3 of them in there. And I read that. So for one scenario, for our audience members who said, "Well, I don't know if AI is on the roadmap." Well, those DL145s could go at edge site locations, and you have the options to slot in those GPUs. And so we've seen use cases where customers with a lot of say micro sites or little storefronts, they want the option to be able to put in a GPU when they're ready to use it that way, because it's not maybe right now, but 6 months from now, after they've just bought brand new hardware, they want to be able to use the latest models at those sites. Okay,
Absolutely.
so
I'm sorry, go ahead.
yeah, last comment, and then let's go to space.
Yeah, absolutely. And one thing I would say is for the DL145, right? To the computer vision, right? More and more companies are using that technology. So when I'm looking at a shelf in a grocery store, department store, right? I'm taking pictures of where customers are focused on their shopping, and then if there's inventory that needs to be reordered, that could be done automatically versus sending someone out there that's counting here the inventory. There's a camera that's watching that those items get sold, and automatically I know how much I need to go back and reorder. So just really, really great use cases for putting AI at the edge.
Mm-hmm. Okay, I wish I had some really cool transition music here, Mark, for taking us into space, but but I think your stories will do the trick nonetheless.
All righty. Well, let's just jump into it. In the limited time today, I want to cover 3 main topics here. The inference engine, which I now refer to as the classic approach, an up and coming method of doing things called federated learning. And then number 3, which we're all getting familiar with, is large language models such as ChatGPT, et cetera. So I think it's important to remember that artificial intelligence and machine learning are in their infancy, and we've got an incredible opportunity to improve efficiency with all of our customers and partners, and we need to focus on that. We're all familiar with Moore's Law and how performance can improve over 18 months, doubling, etc. What we're seeing with inference engines and AI and GPT, that it's orders of magnitudes of improvement. So let me jump into this one right now. Number 1, where you train in the cloud and deploy to the edge. The example we're going to use today is the EVA glove analysis. Astronauts go on a spacewalk, and all during the spacewalk, the cameras are looking at their gloves, trying to identify damage, cuts, etc., for safety reasons. Well, they've generated an inference engine that will take a look at photographs of the gloves and evaluate them for safe use for the next spacewalk. So when an astronaut returns from his spacewalk, he has to take the time and effort to take hundreds of photographs of his gloves in different lighting, different orientations, etc. And then all of those photographs are downloaded to NASA, and they process them to see if the gloves are safe to use again. Well, they've come up with an inference engine down on Earth to do that, to help them do their day jobs, right? And I said, well, why don't you let me run that inference engine in space where the data is? And so we set up an experiment to do that. And as the photos were coming in, they're getting put on what's called the payload NAS. And as they arrived on the payload NAS, I grabbed a copy of them and processed them. And then when the scientist said, okay, Mark, we've just downloaded the last of the photographs, you can begin your processing, I said, I'm done. I had done in 45 seconds what they take typically 5 days, 5 calendar days. It takes that long to get the answers down. So I excitedly said, I'm done. Did I do it right? They said, we'll have to wait 5 days before you can tell you whether you did it right or not. And so 5 days later, we got on a conference call and they said, Mark, good news is, yeah, bitwise, you're absolutely identical, etc. So, and I'll cover a little bit more in that in just a moment. So, number 2, let me go into what's called federated learning. And this kind of goes back to the beginning of the webinar, talking about training versus inference. The classic example is every picture of every cat on Facebook was collected in a data center somewhere, and training was done on it so that you could show a picture and say, is there a cat in this picture? And that evolved into things called CAPTCHA now. We all use that all the time. So, well, it takes a lot of time and energy to get all those pictures into one place to train something to see if it's a cat, to train something to see if your quick specs contain GPUs. To did all that training takes a while. Well, if you can separate the training and make a federation of smaller training units, then the data doesn't need to go in one location. And hence the concept of federated training. You train on separate volumes of data, and instead of exchanging the large amounts of data, you exchange what are called the smaller parameters, the training parameters. And then each of the inference engines takes the new parameters and adjusts them themselves, and they continue to chit-chat back and forth with small amounts of data until they all agree on what are the parameters for the inference engine. So you see that little bullet, more secure. Instead of sending all of your DNA down to Earth in order for them to look for changes in radiation, etc., you send tiny little factors, and then your medical privacy is maintained, your identity is maintained, etc. So not only is this faster and more efficient, it is more secure. So, and we all know about the large language model, ChatGPT, and I've got a couple of pictures. So let's go on to the next slide and we'll get into a little more details, okay? So here's one of those pictures where the spacewalk is over, the astronaut is holding out his glove, and they're taking pictures. And you can see where the AI has identified a glove, i.e., there's a cat in this picture, right? There's a damaged glove in this picture, and there's a red ring around where there may be some area of concern. So, of note, there's a person holding that glove. So this is labor intensive. It takes time and effort to do this, okay? Next slide, if you would. Well, when they came back to me after 5 days and said, number one, Mark, yes, you were absolutely correct. You're bitwise correct. You identified all the areas of concern. But did you know you also processed more than 60 photographs a second? And I said, yeah, I'm sorry. I've got a low wattage GPU. I know the gamers want hundreds of thousands of pictures a second, etc. And they cut me off. And they said, you're missing the point. If you can do more than 60 photos a second, you can do 60 frames of video a second. Would you like to do a second experiment? And instead of looking at stale, tired, old photographs, let's look at the video feed as the astronaut is live doing his work. And there you see an astronaut on a spacewalk, and we've identified the cats in the image and the damaged photographs of gloves in the images here. And we still got green, gloves 99%, etc., an area of concern. Imagine how much safer these astronauts are going to feel if you've got real-time 60 frames per second analysis of the gloves as you're doing your experiment. So this is not only going from days to seconds, this is near real time and affects safety and efficiency of your missions by using artificial intelligence and machine learning. So very good. What's on our next slide?
Mm-hmm.
Okay. All right. Now we talked at the very beginning with Michael about video analysis, etc. And I just did a little bit out with the gloves. Let's turn around to the more boring PDF analysis. Here is an astronaut, and this astronaut is bringing Spaceborne computer out of stowage in order to install it. And what is she doing? She's looking down at her tablet attached to her thigh, and she's flipping through PDF documents. Now, back in the day, they had paper documents, and you had to go find the exact book and find the right chapter and flip through it. For them to go to PDF documents on a tablet was an incredible technology advance. Well, we're fixing to even do much better than that. So we have taken all those documents that apply to Spaceborne computer, installing it, powering up, power down, replacing the blades, every single one of the documents, and put them into an inference engine. So now that the astronauts can converse with the documents. So this is today, and we've given them a glimpse of the future because of ChatGPT-like AI inference engine. So next slide, if you would. All right, we're going to have a little bit of fun. Here is that same astronaut. She is unpackaged Spaceborne computer, and she has begun to do the mounting process of it, installation. You can see she has a ratchet in her hand and a very long Allen wrench. And some of the questions that we can ask our artificial intelligence model is, what tools do I need to install Spaceborne computer? And it's going to look at those documents that she has on her thigh, and it's going to pull those out. And then she can say, where did I store the ratchet? And you'll know where to go get it, etc. She's very happy. She's doing the installation. You can see our HPE green element there. What is missing from this picture and a little bit disappointing is that we are actually mounted in the ceiling of the International Space Station. With zero gravity, I can mount things in the ceiling. And I often say that as soon as Jeff Bezos can get a data center in space, he'll become the first legitimate trillionaire because his data center density will go up because he doesn't have to just mount things in racks on the sides. He can put them in the floor and in the ceiling. So, but that perspective isn't quite there, but she is actually Velcroed onto the ceiling and working as if she were working on a standard rack. So on the next slide, we'll clarify that a little bit, I think. So again, Spaceborne is installed in the ceiling, and here's that same astronaut, and she is taking care of some plants. For mental and health reasons, we kind of want things to grow up. And with zero gravity, the plants are going to grow to wherever the light is shining, but we tend to reserve the up and down side aisles so that we can mentally go by and see the lettuce growing up, etc. And here she is interacting with some STEM students, talking about how to water them and feed them, etc. And if you look over your shoulder, you see Spaceborne computer photobombed her. There's our green element, as we are indeed mounted in the ceiling above her head. So and this is in the public domain, so I'm very happy I'm able to show that and let you know that 150 pounds of GPU-enabled HPE servers are mounted in the ceiling of the International Space Station. Okay, what's on our next slide? If you need to learn more, I highly recommend you go check out Linus Tech Tips. If you don't know who Linus Tech Tips is and you've got some younger members in your family, go impress them and say, hey, have y'all seen the latest video from Linus Tech Tips? And they're going to go, how do you know about Linus Tech Tips? And you've got about 17 minutes of explanation of the Edgeline 4000 and the DL360 and how they are mounted in the ceiling of the International Space Station. So I highly recommend you go check that out. Thank you.
Yeah. And one thing I want to go back to this picture, too, because one thing I think that is so interesting about this use case is that, you know, you have an astronaut installing a server, right? And I don't think,
Yes.
you know, installing servers was part of their training for being an astronaut, despite their, you know, outrageous brilliance and IQs. But I think that's part of the fact of, you know, how we make it easy and you know, how the servers are tailored to be able to be installed safely in that environment as well.
So NASA's a government agency, and as you can imagine, government paperwork is massive and excessive. So these PDFs are far, far larger than any that you would get from HPE on how to do these. So, and a second kind of side story is you can replace the cartridges in the Edgeline 4000. So we sent up spares, and the idea is that we would replace them. We had to write a document how to replace them in zero gravity. And that was very interesting. Things aren't quite the same in zero gravity when you grab something and go to pull it, etc. So that document had to be maintained and updated as well.
Yeah, I think there's some interesting similarities as well with some of the use cases you were talking about, Michael, and how the servers are designed for their environment. And I think in that Linus Tech Talk, you know, he goes more into the storage systems as well and the design considerations there. But some of these computers, and especially this the Spaceborne 2 computer, that one was designed for certain power considerations,
Mhm.
particularly in componentry. And it's kind of like, you know, designing high performance bikes or, you know, reducing weight on a Tour de France bike or something like that. You're looking
Mhm.
at, you know, we only have this amount of power capacity. We can't exceed that. And so how do we design for those types of constraints and draw only as much power capacity as we have or is available?
And I think one thing too, you know, kind of, you know, piggybacking on what Mark was talking about is, you know, he talked about, you know, using the, you know, computer vision with the gloves to, you know, make sure the astronauts are safe in real time, right? And then also too with, you know, talking to the data for the astronaut when they're asking, hey, you know, what tool do I use to install Spaceborne, you know, Spaceborne 2, right? I think one thing that, you know, I don't want to, you know, make sure we talk about is the ability to do that with the same device, right? So when I talk to my customers about the edge, right, it's a huge uplift to get them out of what they're used to doing with traditional hardware, right? So, hey, sir, ma'am, whatever you were doing in the data center, we can take that and push that to the edge where, you know, you weren't able to do that, you know, a couple of years ago. So I'll give you an example. So on a single EL 8000, you could do roughly, depending on how it's configured, roughly about 350 virtual desktops in that EL 8000. Also, two in that EL 8000, in that you know same hardware, 350 virtual desktops. We could add the AI RAG, you know, instance in there. We could do computer vision in there because like I said before, we can leverage GPUs inside of there. So here I'm taking three distinct use cases that were probably on different hardware inside of the data center and consolidating that into something that we can, you know, send up to space, you know, send to the front lines, you know, in a battle. And customers need to really get educated on what the art of the possible is. That's probably what I say one of my biggest tasks is educating customers on, what their AI journey looks like, but also two, what the art of the possible is, because we have really
Right.
great hardware and we can push more and more traditional data center workloads, out to the edge.
Like you said, Audrey, we selected a GPU based on the power constraints. And you heard me kind of apologize at how slow I was, et cetera, at processing those photos. Even as slow as I am at processing those photos, I get you the answer thousands of times faster. So to evaluate how slow that GPU is in isolation is not fair. You need to include the download that you're not going to have to do from the edge to the core. And then we go from months to minutes and then from days to seconds and getting you results, even with these low power devices.
Audrey,
Yeah, that's
can I jump in? The
yes.
question in the chat regarding the glove actually, and the person is asking, I mean, can you speak about the opportunity of the cost of not having to go off-prem with the glove image? I mean, you were mentioning that you're saving time, obviously, but with regard of money, and probably that's not a NASA question, but somehow, how would you relate into a cost-saving approach, computing at the edge?
Yeah, absolutely. So the most common analogy I make is that today our cell phones, et cetera, are kind of free. But back in the day, you had dollars per minute, and you would make calls on Sunday night, right? Well, in space, the calls are not free. So anytime you can reduce your bandwidth, you're saving dollars directly. So not only do I get you your answers much faster, I'm saving you money as well. So I am faster, better, and cheaper in this particular case. And also, when we get to the moon, the costs of communication are going to go through the roof. And when you get to Mars, it's even going to be much more expensive. So you really want yes or no. Is this glove safe or is this glove not safe? And you really don't want to see all that imagery sent back down and have to pay for that bandwidth.
Great. Well, I know we're coming to the top of the hour here, so we'll just wrap up and say if you want to learn more about the Spaceborne computers, there's an easy link to remember there at hpe.com. If you want to know more about all of these different hardware configurations that we talked about today, or talk to someone like Michael, for example, on your account team, please reach out, and with partners as well. And then we always have our professional advisory services to help you explore some of that art of the possible and get to your use case implementations faster. Any closing comments, Michael or Mark?
I just want to say, thanks for the opportunity. This was great, and pairing me with Mark was even better, right? Because we provide a true, edge to, cloud, solution. So thank you for
Yeah, if I say I'm proven in space, available on Earth, and go talk to Michael.
that.
Yeah, whether the edge is a few kilometers away or whether it's measured in light years. It's all an interesting challenge. So thank you for completing the whole questionnaire there at the end, and I'll hand it over to Frederic to tell you more about our developer community.
Yeah, thanks, Audrey. So, as probably if you're aware or if you're familiar with the program, you might have noticed that Didier didn't show up today, and I'm gladly replacing him while he's taking some well-deserved break, I would say. And so, if you're familiar with the dev community program, you know that we have ongoing monthly events, and there are a few in the pipeline. So if you're interested in, Munch and Learn, so you know that there are kind of thought leadership, vendor, product agnostic type of a talk. The next one will take place on February the 19th. It will be about unlocking private AI power, insurance fraud detection, and beyond. So we'll still be talking about AI here for sure. In March, on the 19th as well, there will be a Chat HP hub, sorry, enabling secure and scalable IT transformation at HP. So I suppose that we'll be learning a bit more about our own chat usage. And if you are interested in something that is more technical, that goes in bit more into in-depth on a given technology, on the 26th of February, we'll be doing an introduction on the HP GreenLake webhooks, and I think that Didier will be part of this discussion because he's already has written a blog about the subject. On March 26th, there will be no more blind spots, and you will learn about how eBPF transformed the observability. So that's we did recently some talks about OpsRamp, and I'm pretty sure this will be ongoing on a similar subject. And obviously, there will be some additional keeping real with AI Jam series. There is one that is planned for March. It is to be announced. I'm pretty sure that whenever Didier is back from his break, he'll be promoting the session very widely. And obviously, should you be not aware of this, we still have the workshops on demand, and there are still 30 or more workshops that are being available in our catalog. They're Jupyter notebooks based, and they will allow you to learn about anything that HP provides or some open source subjects. So we've been working on some AI related workshops, and they should be out very, very soon. It's free. It's available 24/7. It's available for everyone, HP partners, customers. So give it a try and provide us with some feedback, please. We'll be very, very happy to hear from you. And yeah, there's only one slide left. Anything that you should know about the dev community, you can join us on Slack, you can join us on X, you can record or register to our newsletter. Should you be willing to know about what are the latest and greatest things that happen in the community, should there be events or meetups or blogs or whatever that we are able to produce. And obviously the workshops on demand as well. There's a QR code, you can just scan it and you'll get all the links available to you in one shot. So keep this slide in your slide deck, and that's the best way to promote the community and make sure you have you and your customers and everyone you know join the community. The more the merrier.
Thank you very much, Frederic,
You're
and
welcome.
thank you, Michael. Thank you, Dr. Fernandez, for joining us and being our guest speakers today. And thank you to our wonderful audience for your attention and for your questions.